This is your weather briefing for June the 3rd, 2019, also known as week 6 in the summer 2019 term for the Weather and Climate course NATS 1780. I hope everybody's doing really well. Things are progressing swimmingly, as they say. The emphasis for this week from a content perspective is to continue our emphasis on the atmosphere in a state of motion. We started that last week with our discussion on pressure and wind. We're now continuing along with that theme by looking at wind on scales that actually the emphasis will be on really the local scale. This will give us a chance to speak about such phenomenon as lake breezes, which interestingly enough this year have not been that much of a factor in Toronto with the interesting spring weather that we've been having. Lake breezes are most pronounced when there's a very significant contrast in temperature between land and water. So we did have a pretty substantial winter, as everybody probably still remembers. So the lake would have been pretty cold coming into the month of May, but we never really had daytime temperatures that got into the high 20s, 30s on the Celsius scale. And so as a result, we really didn't have much to speak of in the way of real lake breezes. But that is the emphasis, nevertheless, in chapter 9. The lake breeze phenomenon, which, as you may have gathered from what I've already just said, has a lot to do with the ways that different materials, in this case land and water-based surfaces, respond to incoming radiation. The fact that they heat and cool at different rates. So this differential heating and cooling also factors into a completely analogous, what we call a thermally driven circulation on a much larger scale, a regional scale, in places like the Indian subcontinent, and factors into the phenomenon known as monsoons. So this is a great circulation to study. Circulation is movement through a circuit, as you'll learn from the lecture material, and it turns out to be pretty important because we'll use this as a way of taking on a simple circulation that we can understand fairly easily. And then we'll look at circulations on a much broader scale. And that's what the subject of chapter 10 is really looking at wind systems on that global scale. We'll come up with a model for the general circulation of Earth's atmosphere. We'll start off with a very nice conceptual model, which we'll systematically refine by relaxing assumptions, by introducing additional complexity, and we'll end up with a pretty decent model for the overall circulation of Earth's atmosphere, which will prove to be quite useful to us in a number of different regards as we progress through the course. We'll also take time to understand some of the interactions between the atmosphere and the ocean, and explain phenomena such as the El Nino that you've probably heard about. So much for some of the content. Quiz 2 recently closed. Quiz 3, as you can see, closes June the 23rd, so there's still plenty of time left for you to take Quiz 3, which focuses on chapters 6 and 7, and I will try to put together and release Quiz 4 for you fairly soon. The labs you do have before the start of reading week, you have Lab 2, which emphasizes humidity. It's due on June the 9th, so I just wanted to give you a little reminder for that. Let me also just take a moment to reflect upon humidity in a practical sense. I'm actually in Las Vegas as I'm recording this particular weather briefing. I'm here for a conference, honestly, and you can see that it's pretty warm here. It's 32 Celsius. But the most interesting thing and how it relates to that discussion of humidity is that the feels like temperature is actually less than the actual temperature. So it actually feels only 30. And I apologize for sharing that with you if you're in Toronto today, because it's not anywhere close to this warm. So what's really interesting here is that usually when we think of humidity, we think of humidity and the amplifying effect that water vapor has in Earth's when it's present in Earth's atmosphere. So typically in a Toronto summer, we'll have periods where we have extremely humid air, and it makes the atmosphere, it makes the air feel significant, in some cases, significantly warmer than it actually is. You've probably heard about, this is referred to as the humidex, for example. Well, guess what? When the humidity is really, really low, as it is here in Las Vegas today, it's only about 12%. It's very low. The actual impact of humidity on the ambient temperature is to make it feel cooler than it actually is. So yes, humidity typically, and certainly from the Toronto experience, it typically is something that makes for muggier days, but in places such as Vegas, it can actually feel cooler when the humidity is really low. And sorry, I just remembered another connection that I wanted to make here. A couple of years ago, when there were some horrific wildfires in Alberta, particularly the Fort McMurray wildfire, they were having days like this, days on which it would get extremely hot, so 30 plus Celsius ambient temperature, very, very low humidity. So those were contributing factors to the forest fires that occurred at around that time a couple of years ago in the northern Alberta area. Okay. You also have a lab on forces, and I gave you some nice lead time on this one because hopefully you can take some time out of your busy schedule and enjoy some time going to some place such as Canada's Wonderland, where you can actually feel the forces as the lab encourages you to do. Places like Wonderland are ideal for, particularly for experiencing ultimately the Coriolis force due to being in a rotating and therefore accelerated frame. All right, and then as far as assignments go, we are working on, I should probably say before I move off this topic, I'm fairly certain that the marker has finished marking all of your Lab 1 submissions, so you should have a grade for Lab 1. You'll either have a not satisfactory, which means that you didn't meet the minimum, or you didn't submit the lab, or you didn't meet the minimum criteria that was established for that particular item. Satisfactory means that you've done the work adequately, and outstanding means that your lab is of excellent quality. Assignments. Assignment 1 is currently being marked. I'll try and get updates for you on that. Assignment 2 at this point is a feature that is coming soon to a Moodle site near you. Just one other thing in passing on my weekly update here. You may have already heard about this, but apparently a tornado sighting was made in the Orleans area, Ontario area. So this is basically Ottawa Valley area. Let's see, Ottawa suburb essentially, located right along the Ottawa River. So, just another interesting connection with our course. We will be, you can see the URL for this here. You can find it obviously by looking at the Weather Network and no doubt numerous other sources. We will absolutely be taking up the topic of tornadoes as an example of severe weather when we get to that point in the course. So I think with that, I have completed what I wanted to share with you for this week. So there will not be a lecture released next week because it's reading week. So, however, even though lectures aren't given during reading week, you're certainly welcome to continue, engaging in dialogue with myself and your peers via the course's Moodle site and whatever else you might be up to with respect to the course. and I will be responding to you. So, with that, I will finish up this briefing, get this posted online. I'll also put out my weekly message and look forward to continuing to engage with you online and speaking with you soon. And if you don't happen to hear from me before the time comes, I hope you have a very good reading week and that you make excellent use of it, and of course, whatever that means for you. Have a great week and bye for now.